list of this agenda from a quarter over two to 2:30. We will have our director Ian Stan. He will give a general speech about the general open source strategy from Alliander, followed by two use case presentations which use this Power Query model, and that is Project Delphi from Brian Timmons and Project Impact from Thijs Bayen. Then we're going to have a short break. I'm going to present a bit about our achievements, developer achievements on Q3, Q4 this year, and of course the interesting part is the brainstorm on the wishes on the new features. So then that's where we need the input of you, all of you guys, the community, to see what we are going to do next year, and that will be based on what kind of feature requests, wishes coming from the community, including both internal Alliander people and other people from the external parties. And of course, at the end of the sessions, we are going to have drinks and do some networking for all those people who are on site. And there is also the moment we merge together with the people on the upstairs. So without further disturbing, Ian, the floor is yours.
Yes. Thank you.
Yeah, this.
I'm trying to share my presentation in the Teams.
Oh yeah, that's all.
This is it's not working, yeah. But this is the difficult part of the presentation to get the PowerPoint working here on the screen. Now it crashes.
Do you need help?
No, I'm almost there. I think it's this one. And otherwise I have to share my screen. Something is coming, I think. Takes a while, maybe. Yes, there we are. Well, thank you. Thank you for being here, Alliander. We were really surprised to see such a large crowd joining this meetup, and it feels like an honor that you guys took the time and effort to join here today. Well, my name is Arjen Stam. I'm responsible for system operations, but I'm also a large adept, basically, of open source software. I'll dive into that a little bit later, because we took an all-in open source approach towards what we had to do with system operations. I will address that shortly. And I think today we will have a short overview of how we deal with that in Alliander, because it's a strategic theme within Alliander, working on the axis of open source. And I already saw two persons that are all also very active in open source. That's Nico Rikke, but he's not in picture, and Jonas van der Boogaard. But I'll talk to you about our open source. A lot of text, but what it comes down to is we chose to go to a large extent on open source, especially the system operations department. It's a new department, 2 years old. And from the start, we decided to do everything based on open source. But within Alliander, we already do it quite a while. We're more consumer. We contribute to once in a while. But open source is also part of our strategy. And my conviction is also that the energy transition won't work without open source. And I think we will see that a little bit later also in the ecosystem that we need in order to do the energy transition. I have made a quick summary of our open source strategy at Alliander. First of all, it's about the mental model. So are you willing to share and to collaborate? That's a fundamental principle. It's happening in your head. If you want to do that and you're willing to do that, it's about the basic transformation, because in the past we were quite a buying party in terms of software, and now we're creating party and collaborating party in terms of software. And that's also a big transformation, because it requires different attitude, different processes, different roles, and that has a large impact on how IT works and how your department works. It's all about sharing, and it's not so much primarily about sharing code, which in the end it is, but it's about sharing. And that's also a very important part, because if you share knowledge in the public domain, which you do in working in open source, what we see is that the quality increases, the attractiveness increases, the robustness increases. I think it all contributes to what you actually need. You must also be willing to get rid of something that you really love, and that's typically code. So if you contribute to something, every developer really thinks his own code is the best, and that's of course that's true. But sharing it, and with the assumption that it can become better or more extended or whatever, that's, I think, a fundamental principle as well. So you invest, we as Alliander also invest time and share it and contribute to someone else, not knowing exactly what we get back from it. But that's not important, because you know in an open source context that you get something back from it. It's not determined really yet what you get back from it. It needs to be secure, and that's also typically also within Alliander still. Not everybody has the same conviction as me about open source. So the first thing you need to address is it's not secure. And I think that's really interesting, because if you look especially to the security part of open source, to a large extent, security software is also open source. And the reason why is it becomes more secure. And that's a sort of contradiction in a lot of heads. But you need to be very careful about how you apply your code, your code checks, your code quality, reviews, etc., etc. Yeah, and when it's there, you need to maintain it. And that also requires that you really are convinced that you need to supply an effort in order to get that to work, that you can maintain the code and make it better. I threw in some statements. I have, I think, too many slides for 15 minutes. But one of the arguments that also come across is it's much more stable, and well, that's a characteristic of robustness, basically, and I think that makes sense. And what you also see, and that's why I'm presenting it here also today, is we are also from system operations building a mission critical system. So it needs to be available 7x24 with downtime less than an hour, etc., etc. And we choose to go open source because we believe that it's achievable with that. Well, this is of course nothing new, I think, for a lot of people here in the room. All kind of open source project, and also a lot of dependencies we have to manage. And the question is, how do we do that? So this is one of the questions I addressed earlier. Proprietary software is not necessarily better, because sometimes they use open source as well as part of their solution. But it's attention to the quality of the product that you want to achieve. So that's a mission actually of the community to make sure that this is happening. So it's all about how people are addressing this. So in order to manage this within Alliander, we have instantiated an open source program office, an OSPO. Probably most of you are familiar with that. And for us, it's mostly, so this is actually a sort of blueprint of what you can do, what typically are the responsibilities of an OSPO. And for us at the moment, and I'll come to the maturity of our OSPO shortly, but is helping our organization decide which kind of solutions are most usable within Alliander, which ones fit best, because we still have to build a lot of software or to implement basically a lot of software, not necessarily build. And the question is, which one are the most suitable for Alliander? So we can help with that. Also organizing, helping organize community events, managing the community itself. That's also how the OSPO contributes. Also creating new open source projects. So if we, for example, the Power Grid model, what we also do is help around that to see how we can make it flourish, attract new contributors, etc. And the last one is also monitoring the open source performance and security with tools. So what kind of dependencies do we have? What kind of licenses do we have? Are we still compliant? Those are also things we do from the OSPO. And the organizational form, the OSPO here is a virtual organization yet. We haven't done, it's not a physical organization at the moment, but since we're growing, it will probably become at one point a physical department. Now, what is typically people in the OSPO? Now, business sponsor, that's me. We have enterprise architects and architects in general. An open source office lead manages the daily activities because there's a lot of interaction between the different programs and also with the outside world. That needs a little bit of attention. Advocates, we need to make it more popular, people to understand how to adopt open source, how to use it, and in a safely manner. Well, there's a community manager also necessary. That's a new role we identified. We grow iteratively. So if we see we miss a role in order to get the open source working at Alliander, we see what we need, and a community manager is typically a role we need as well. And of course, community development is also something you need to spend time on and invest in order to grow a community. And of course, some legal and marketing and communication. So you can find, for example, on the website, also a separate part that is about open source and open source projects of Alliander. So once you have it, you need to do something with it. You need to maintain it and to keep it safe and keep it productive and develop it through, because there's always new requirements. Well, we think in Alliander we have a process. Most of these processes are in a way implemented, but not all of that mature. So what we did is a maturity self-assessment with the open source maturity model. And that's about, on the one hand, open source management, and the other hand, open source usage and contributions. So it's about lifecycle management, risk management, compliance management, and security management. And the use of open source, the contributions to open source publications, and inner source. Inner source is basically the version where we started with. So let's start sharing internally the code and reuse code and document code properly and test code properly before we really went to open source. And we still have to grow that as well. So these are the levels to which you can weigh that. 5 levels. I don't go over them. And this was the outcome of our self-assessment at this point in time. We were quite critical because I didn't agree with the twos everywhere, because I think at some point we are more mature, but it's in general. So also the parties that just started and the parties that are more mature, so in general. I think we're quite well under the way for the short time that we started working on it. And we also see now the attention points where we need to invest with the OSPO and the open source working models in order to get to a much higher maturity level. And that's really what we also want to achieve. So it's really part of the strategy of Alliander to get there. There's a lot of arguments is about also reducing investment and cost, but you can also turn around the discussion and say, okay, if I spend money, I want real value for money, and I get more value if I contribute and work together with other parties and share. So how do we apply it to what should I say? Within IT, we use different components. And for system continuity, a strategic team with Alliander, we use all open source. And this is basically the process, the main process within system operations we execute. So what we do within system operations is managing flexibility in the grid. So what do we have to do? We have to measure. So we get a lot of data points in. We have to get a picture about how the state of the grid is. That means also topology data, asset data, customer data. Then we need to identify if there's a problem in the grid, in its current state or future state. How can we mitigate it? And if it's mitigated, there's also a kind of administrative tasks, like clearing of a transaction or reporting out to customers. And then we do it all over again. So where does it consist of? So first, we do the short-term forecasting. It's an open source project under Linux Foundation Energy. We contribute to that quite a lot. That's doing the forecasting on the measurement data. And we use that to do the state estimation, and that's where the power grid model comes in. This one was actually born with the business need that we want to have a full state update every 15 minutes of the grid. So we put it previously in other calculating tools, and only with a small part of the grid, there was already calculating for hours. So that was not a feasible solution. So I came into a discussion with Tony. Can we speed up the calculation for the state estimator? It doesn't have to be very accurate, but we need the speed. So within a quarter of an hour, because that's the frequency in which we control the grid, and it's even too slow in certain in certain situations. So it needs to be 5 minutes. But can we do the whole grid, medium voltage and low voltage, within 15 minutes? That was the question. So Tony started off with some research and started working with university and colleagues. And then the power grid model was actually born, because it really helps us to fix this. Well, then the following step is, and that's more the reason why we can do this open source is quite generic. So doing forecasting on time series is rather generic. You just have to look at the model you use and what you want to forecast. Is it the crossovers at 0, or is it the peaks? That's typically what you have to look at. So that's how we apply this one. State estimation can also be applied very generic, but dynamic safety analysis, that's more specific. So we actually want to open source this as well. But for us, that is, you have to have a topology. You have to have determined the state of your grid. so loads and voltages and your connectivity, and then identify based on the limits, and the limits can be well, the physical limits, the temperature, or policy limits like the amount of power. But this component determines, is there an issue, congestion? And if it is, then we have power capacity manager. That's actually looking for the resolution of how to resolve it. So if we have multiple stations connected with cables, and we identify one or more contingencies, that's how we call a problem in the grid, contingency. We also virtualizing our talk when we talk about the physical grid. There's the contingency. And then we have several options for applying flexibility in the grid. And then we have to optimize, basically, and that's the next question, that's with Tony. How can we simulate and optimize which solution is best, and well, according to some criteria, cheapest, least client impact, that we can apply in our grid. And then when the solution, so this component determines the solution, and when it's determined, we need to execute it, and then all kind of interaction with an energy market or with the client or that kind of things start to happen here, and we have to monitor that. So this is what we do from a forecasted data, and this is actually after we have determined there's a contingency tomorrow at 2. We just have to monitor and see if it's executed properly, and if it's done, then we need to do admin, etc., etc. Now we all monitor it, not in a control room. Our control room, I don't know if you've been there, but our control room is here for the grid operators. And we are building actually our virtual control room. And that's also an open source project, Operator Fabric. We built it together with RTE. And one of the other criteria is we need to be very, very flexible in our processes, because regulation is changing. The way we want to use the grid is changing. Everything is changing. And that's why we choose Camunda, which is also open source. Yeah, and maybe last. So we are part of LFE, Linux Foundation Energy. This is typically the projects that are quite popular now there. And we see the community grow there as well. We use quite a number of products here. We use the Operator Fabric. We use Compass for substation configuration, because substation configuration, believe it or not, today is done through Excel. And we need to, if we want to use a substation configuration language, CPath is in scope. The Grid Exchange Fabric, that was previously called Smart Grid. I don't know. But that's one we brought in as well. OpenStaff, that's the forecasting module. That's what we brought in as well. And this is the one we use for protocol conversion and the scheduler. So if we really want to have autonomous decentral control in the grid, this was one of the building blocks we're going to use for that. So this is a short overview of open source at Alliander. Thank you. I don't know if there are any questions.
You mentioned the brief period that this has existed, but when did this all start? And within Alliander?
I think the OSPO, you mean?
Yeah.
Yeah. I think it's more or less 1.5 years ago that we formalized it.
All right.
Yeah. And we just said we're going to build an OSPO.
Yeah.
There was no OSPO. And then we were looking for enthusiasts that wanted to help. And that's where Nico Rikke and Jonas came in, and also Peter de Koning from Alliander IT. Yeah.
Cool.
Yeah, and the challenge with an OSPO also is to find the appropriate mix of business people and IT people. Because you want to have an understanding of why you are applying open source. So from an IT perspective, I have an IT background myself. I'm now on the business side. It's really cool to work with cool technology and go into the coding. But from a business perspective, it's really good to have the context available for why are you doing this, and that helps enormously, I think, in bringing focus and making choices of how to implement your open source strategy.
Because it's not like you always want to open source anything you build within the organization.
No, not
Terminate per project.
Yeah. And also if it's buy or build or download. But even then, sometimes it's not beneficial to start building something, or an open source product is has a big functional delta. Then we still buy software, so that happens. But also from the OSPO, we are working with the procurement department when we go for a tender, that we also get the open source option in. So it's not, that's why in the beginning it says transform. It's not really trivial to get an open source tender out if you're used to tendering in a commercial environment. So that needs work, and that needs adaptation and change. And it works out in the end, and we benefit from it. But it's not a trivial thing doing open source in these kind of organizations. Any other questions? Okay, this was the boring stuff. Now we can go to the.
So I think floor is yours. Bram.
Great.
Mag ik die ook gebruiken? Kan je er ook lukken? Ik denk niet. Share dan.
Even uitzetten. Dan ga ik wat er al opbrengen.
Oh, yeah. Loading. So welcome everyone. My name is Bram. I'm a data scientist at Alliander. I'm working on the product Delphi, which is a decision enabler on low voltage impact. And I just want to give a quick insight in how we use Power Grid model, or why we use it, and why we need like a big calculator on our low voltage grid. So basically, because I've understand from Tony that some of you are new to Liander and our grid. I wanted to tell you to begin with some quick insights into our low voltage grid. So when you look at it, we have over 3.2 million customers in our low voltage segment, with at least 35,000 transformer substations which we need to manage. And actually now with the energy transition energy or approximate, we replace around 1,000 new substations or transformers each year. And to illustrate like why we need a decision enabler on our low voltage grid is like if we look at the upcoming 5 years, the number of voltage complaints due to sun panels or electric vehicles is going really fast and really going up exponentially by approximately 10 or 25 times. And actually, due to the visibility constraints we have at Alliander to place new stations or replace new stations, we actually think that even the number of complaints are going up more going up more in future. And if we look even further for the upcoming 40 years, so it's not the short-term forecasting that Arjen told about, more the long-term forecasting, we also see that capacity problems arise in our network at our transformer level or at our cables. And we also notice that there's a lot of uncertainty in what direction this is going. We strive with our tool to actually make future-proof investments so that we only have to go back to the same station once in the upcoming 40 years, so that we adjust the mitigation steps we take are to take into account the necessary adjustments we need to make for the future. So basically, how do we do this? So we have a decision enabler in like 5 steps. So the first step is that we make forecasts for how our network is going to transform. So where are the electric vehicles coming? Where are the sun panels coming? And when are they coming in our network? And from this, we model like future customers. How are our future customers going to look? Do they use electric vehicles? Do they have sun panels? Do they use heat pumps, etc.? And from this, we model or we use loads modeling to translate the current loads into the future loads profiles, which we can then use where we use our smart meter measurements to actually simulate those profiles for the future. And this is from this point on, we use power flow calculation or the power grid model to perform a load flow calculation on our network to provide information about the currents and distribution of currents in our network. And finally, we can see like what is the impact, what do we need to do as an organization, and how can we adjust our work life now to benefit proactive investments into the future. So actually, what is Delphi? Delphi is just one big calculator on our low voltage grid, where we take our adoption models or the forecast and use our network topological data and the connectivity data to actually simulate what's going to happen in the network in the future and where bottlenecks or contingencies, as Arjen said, arise. So basically, just to give a quick insight in the inner workings of the model, I'm not going to share code or something because Tony Selman just keep it plain. But well, this is the best I can do. So actually, we have different forecast scenarios that we use, and we use different steps in our big calculator to actually go from now to the future. So we have adoption modeling, loads modeling, that I just told about, and then we use a kind of stochastic procedure or sampling procedure to actually simulate what is going to happen per sample by doing a load flow calculation. And as you can see, like because we have a lot of time steps and a lot of samples that we take, this quickly multiplies, and that's why we use cloud solutions or like AWS or Azure to actually parallelize our calculations to make them faster. I'm going to talk about it later. So basically, to zoom in on the adoption modeling, so we have like adoption curves, which illustrate like how many electric vehicles or how many heat pumps we expect in the upcoming years. And if we look at like how and we from the insights that we have from studies or studies that are done at the universities or at other institutes, we can estimate where are those electric vehicles going to come in the future, and we can see like what is the chance that a certain connection is actually going to a household maybe is going to adopt an electric vehicle. And from this, we sample according to these chances, like different scenarios for each year in how this is going to look in each low voltage grid. Then the next step is that we need to identify like what is going to be the future load of this household. And for this, we use like a measurement from our smart meters, but also from measures from other substations to and we use a clustering approach to actually cluster those customers in similar loads. So you can imagine that we might have school loads that we identify as schools or loads that we identify as households with a heat pump, so that you have different clustering of those measurements to determine the base load of these future customers. And we also use like internally made or more deterministic models to actually simulate the future load profiles that that's going to be adopted by those customers in the future. From there on, we have like the future load profiles that these customers are going to adopt. From there on, we can do a power flow analysis or use the power grid model to actually use our bottom-up load profiles that we simulated, plus the measurements that we have at the substation level to simulate where are the contingencies or bottlenecks going to arise in the network. And we can actually see like where is going to be voltage dips or voltage exceedances according to our threshold or bandwidth that we set, and also capacity exceedances or bigger problems in our network. So how does power grid model fit into our model? The main reason is like we do need to do many power flow calculations, and this really adds up when you also use a stochastic approach to this data. So yeah, we have at least 35,000 substations that we want to, where we want to do a power flow calculation. Plus, when we want to do it in a time series approach, so we want to really stretch it to each time steps in our time series, maybe in a 15 minutes dimension, then it really adds up when you also use a stochastic approach. So for each sample, you can think about 35,000 calculations that we need to do with PGM. And that's why we really need our calculation core to be flexible and optimized for speed. And that is, for us, the main reason why we want to use power grid model. Also because you're going to look like what we want to do with our model is we can actually give a really detailed analysis on how the impact is going to be on maybe flex or smart solutions like smart charging or PV capping the PV impact, and what's going to be the impact on Alliander or the investments that we make. And this is maybe a good illustration. We saw that for smart charging, the impact is really not the simple smart charging. So between 5 and 9 kept the charging capacity of cars, really had no impact into the investments we had to make into our low voltage grid. And another thing that we can do with our model is give insight in how many contingencies or bottlenecks are going to arise in the future, and how fast we see these problems arise, and what are the first problems that we see. So we actually saw that now we see a lot of voltage complaints, but it's actually going up in the upcoming years. And after voltage complaints, we see a lot of capacity constraints or contingencies arise. And we also can see like what are the number of mitigation steps we need to make or we need to adjust to counteract these contingencies or bottlenecks in the future. And this is my final slide. So what it actually helps us in doing is really making proactive decisions and justifying those decisions for the future. And that's really what we strive to do with Delphi. So use forecast to actually justify our investments that we make into our low voltage grid, and actually doing them now, so we don't have to do them in the future. So this was my presentation.
Thank you.
Are there any questions?
Can I ask one?
Yeah, sure.
Yeah, thank you for the presentation. I want to like, are the other models involved in this Delphi project also open source? Like how the adoption model, something like that?
No, it's all inner source at the moment. It might be that some of the models or aspects that we use might become open source, but I'm not sure in the short notice.
Yeah,
because
sure.
it's really still in development. So it's really, we need to make it open source. We need to do a lot of work still, I think.
You can look at Jonas, right? He's ready for us.
I think we're not ready yet, but maybe in the future we are. problem is that we use a really cloud infrastructure to do these calculations, and I'm not sure how to adopt that for an open source approach.
Is Delphi now also used to determine the priority of the investments in the low voltage network?
Not directly, but it helps us in making those priorities.
Okay.
So
Because
yeah, so
I was wondering if that's the same.
we are the input for the pre-load,
Okay.
yeah, or are going to become one of the inputs. That's not the only thing that determines the priority.
Yeah, I have one question.
Any question from online?
Hi. Yeah.
Hi. Yeah, go ahead.
Hi. I think in the slides of 7, there are 2 scenarios. I see there are big difference in these 2 scenarios. How you build the scenarios is randomly built or based on the forecast of how much for example, the PV penetration in the future and EV penetration in the future.
Yeah, so normally we have, for each technology, we have 3 scenarios, which is the low scenario, medium or high scenario. And in a low scenario, we expect less adoption of a specific technology. And when we go up, we expect much more. And for the scenarios, we are wereldbeeld station.
Okay.
Broad picture, yeah, we use different configurations of scenarios to actually simulate what is going to happen in a scenario where we see a lot of adoption of new technologies and scenarios where we see less adoption of technologies.
Okay.
Most of the time we use the medium scenario that we have to determine our investment horizon.
Okay, thanks. Yeah, I see. So this combination of 3 levels of scenarios and makes the calculation.
3 level, yeah.
Yeah.
That's correct.
Yeah, thank you.
Any more questions? Maybe online? Oh, I see somebody raised their hand.
We can see.
Yes.
Please go ahead.
Good afternoon, everyone. I would like to ask what will be the possibility for making clustering power flow or parallel processing, and how much is the performance of the speed up of this kind of process?
So basically, at the moment, the power flow calculation isn't our bottleneck in our calculation, it's the loads modeling. But previously, the power flow is then, so we used internal models to do a power flow model, which for each power flow, it took about maybe 10 or 20 seconds. But because we need to do 35,000 power flow calculations times the number of samples that we take, that can take quite a while. And now that we use the power grid model of the team of Tony, I think it's now optimized that one calculation only takes 0.1 second. So if you multiply that, it's a speed up of like 20 times or 40 times in our calculation. But now we more fixed on fixing the bottleneck or the bottleneck in our calculation that we have in our loads modeling that we use.
And normally you are depending on linearized modeling, or you use non-linear model actual for this kind of device?
It depends. So we want to have the flexibility, we want to be flexible in what calculation method we use. For like the really big calculations that we do, then we use the linear approach. If we go to more like maybe more in-depth analysis, then we might use another approach, but it really depends on the situation.
Okay, much for you.
I think there's another question.
Yes,
but
I think
maybe
it's
it's the same hand.
It's from Irina, I think. Yes, go ahead.
Yes, I have a question.
Yes.
I have a question about the smart meter measurements that you use for the bottom-up profile generation. Is it for 1 year, multiple years? Is it throughout the entire Alliander network, or just a subset of it? And do you renew it basically every year if it's for multiple years? Like, do you add data to it?
So for the clustering approach, we use what's called the pulse profiles, which are a subset of our low voltage clients who accepted that we use their measurements for these kinds of studies. I'm not sure how many customers that are. It's in some of the thousands, I think, 10,000. And we use that to determine. So we use the base loads from the last year to determine or clustering or what clusters arise. But we use some subset of criteria from previous clustering to determine the same number of clusters, that we have similar profiles for each year.
Okay, thank you.
Maybe I have a question about your parallelization. So you mentioned that the parallelization, I wonder, is that the parallel is you have multiple AW instances to calculate each individual LV network?
Yeah. No, we use two parallelizations. So we use the parallelization inside the power grid model. So we use and we use a serverless approach in AWS to have multiple incidents that do a quick calculation for each substation.
So how many cores do you usually start per instance?
Well, our instances are quite big, so that might be in the memory range of I think 80 gigabytes. And we parallelize about 30 instances each time.
Okay. Thank you. Question? And well, thank you, Bram, for a very interesting discussion and presentation. And guys, yes, first yours. We have another interesting presentation from Project InPy.
I hope. Is it working?
I don't know, is that the right time for very specific question, very technical?
Jason, what do you want to ask?
Actually, I'm trying to integrate a Power Grid model in Possible. So Possible that is written in Java, and so that's an interesting job. And so what I see that the difference between the way I think that's the difference between TSO and DSO probably, I guess, I don't know. But our generation we used to model them with the voltage that is constant, and with your load gen type, you don't have this ability to have a voltage constant. So that's only at the source type of node that you can have that. And do you think that would be possible to have this
yes, I think,
yeah.
Yeah, a very interesting question. So actually, we have in the later after this presentation and the break, we will have the brainstorm on the wishes on new feature requests. I think that is actually one of the features I erased many times. So you can then later put your idea on the mural board. But let's save it for another half hour or so. Yeah.
Okay, that was I didn't know if that was the right time to ask that question. So thank you. So I'm waiting.
Yeah, thank you.
All right, hello everyone. I'm Thijs. I'm going to talk about InPy and Power Grid model. First, a little bit about me. So I'm Thijs Baayen. I work actually at Codebees, external employee here at Alliander, but been here for about 3 years. My role within the The IMPI team is the data science engineers. I help our data scientists within the team to maintain the software quality of our project and think about architecture, like incorporate their models into a bigger project. From Amsterdam, and I originally studied psychology, but I've made a bit of a career switch. Small disclaimer for my presentation, I've used for fun an AI to generate some of the images in the presentation. So if you see any strange images, they're from the AI. So I'm going to talk about these 3 topics. What is IMPI? How do you use it in our project? And then a small extra thing, if we have time, about the Alliander Python grid. These are some of the images. So the Dutch government goal is, as you all know, is we're in an energy transition flow. And by 2050, we'll have bikes that run on windmills and we'll have chairs with solar panels. But more seriously, we have everything is changing to electric, or most things. So a big thing that needs to change also the network that you're all familiar with. And I think in summary, you can say we're going to use a lot more electricity and less gas. So we want to make that transition. And for Alliander, those goals, that goal translates to we want to still be able to connect clients, minimize congestion, minimize power outages, and minimize costs. But we have limited resources. We have limited technicians. Also, money is somewhat limited. Materials, mainly it's the technicians that are an issue. And we don't really know what kind of resource we will need for the next 20, 30 years. So we have a bit of a resource problem in terms of what we need. But we're pretty sure we don't have enough resources for the next 20, 50 years, at least in terms of technicians. So we want to use them as efficiently as possible. So what are the required resources is our first question, and how can you use them as effectively as possible. So there comes IMPI, and IMPI is a similar project as Delphi, but we are mainly focused on the medium voltage grid and high voltage. The IMPI stands for Integral Net Planning with Artificial Intelligence. We also have an artificial intelligence part of our project. We want to help Alliander's business come up with a strategic plan for the next 30, 40 years of which investments to make every year. Alliander already did this, but they did it more or less by hand. They come up with long-term plans or big Excel sheets, which tell Alliander we're going to do this in this region, this in that region, this in that region, and we have shorter-term years. But it's all made by hand and based on expert knowledge and things like that. We want to make it more data-driven. And goal with IMPI is to make these plans for the long term, make them data-driven. So kind of predict the future, see what solutions fit best, and then come up with a plan like that. So it's a really complex picture of what it tries to entail, what IMPI is about. We are simulating the grid, which you see in the lower part of the picture, of Alliander, and we try to incorporate all processes that are involved with Alliander. Eventually, we wanted to do everything, but for the moment, we are focused on medium voltage and high voltage. So our base internal model is a grid, which is similar to the power grid model. And to give you an example of what we do, we simulate the next 40 years within our data model. So we have our grid, and then we do 40 years of mutations on the grid. And there are two kinds of mutations, you could say. There's environmental effects. It's things we don't really cannot really control. So cables become older, which make them more prone to fail. Cables will fail, or other assets will fail. And also there are applications from clients. We get that information from other teams, but we don't really control who's going to make up their mind to say, I want a new connection. So that is things that are coming into our simulation or affecting the assets within our grid. And then we have actions Alliander can take. So Alliander needs to restore power flow whenever assets fail, We need to restore assets or repair cables or something like that. We want to process the applications from clients. And an important one is we want to add network capacity. And there we can make a lot of choices, like how do we add new network capacity to the grid? We also can digitize the network and perform maintenance. That's at least things we need to do. And the question we keep asking ourselves, how can we do this effectively as possible for the next, especially if you look long term. So back to this thing. The thing in the middle is the AI. So one part of our project is to let the AI, we eventually want to train an AI to make these decisions. So it's more basically about giving budgets to specific parts of specific actions. And after then running the simulation, you get a bunch of KPIs to see how well you are performing. You give that a feedback to the AI, and you run their simulation again. And so with a lot of training, you hope to come to a optimal solution to your problem. So your plan for the next 40 years based on AI. But most of the time for now, we've been focusing on the ENP part of the project, so the simulation, not the AI. And let's continue with that part. So I'll give you two examples of how we use the Power Grid model in our project. And one of them is for processing client applications. And I did not get a memo from Tony to not include code. So there's a little bit of code in here. But this is how we represent the grid. And I think for those of you familiar with the Power Grid model, this is the D types or the data types that you will also find in the Power Grid model, represented as a data class, the grid. And we put these arrays in there. And then this is an example of where you can, for example, a situation where you have a grid. And let's say there is an application from a client. I just wrote this today, but it's just example code. Application from a client with some requested power, and it wants to connect to this node. This is the top node is a substation node, you could say. The blue smaller nodes are real nodes, MS nodes, medium voltage nodes, and the white lines are what we call Haldane lines. And we want to connect a new client. So we connect that client in our simulation, and then it's not much more code than this, I promise. So this is our process for connecting a client. So we start with a healthy grid. Then we based on the X and Y coordinates of the client, we find a suitable node for the client, which is in this case, so the nearest node, for example, we find node number 7. Then we add the application requested power to the node, and we check whether with the load flow for example, in the grid has overload function, we do a load flow. There we use the Power Grid model, and we check whether there are any overloaded assets as a result. And we try to do that, and every time, for example, the result is that some assets become overload. We reduce the power of the application, and we try to do it with a lower amount of requested power. In the end, we'll end up with at least a healthy grid, but in some cases, the application will not be given any power. So we end with a client power limitation. I'm not really sure how to translate that to English, but that's in any case we'll end up with we'll keep a healthy grid. So this is the process I was talking about. So the power flow, the load flow will return new loads, and then for example, this node could then be overloaded, and this line can also be overloaded. So that we will then remove that requested power from the application, but we will keep in mind that the original client originally wanted more power. So we have a transport limitation then. And so in another example where we use the Power Grid model is in the next step, actually, when we have connected clients, but they are limited in their power. So we want to add network capacity so the clients can get the full power they requested. So we have this situation again, and there are, as I showed in a previous slide, there are multiple ways to solve these power congestions. And in this case, we pick, for example, the add new route solution. So we create a new line between 1 and 7, node 1 and 7, and we close the line between 5 and 7. So that's, in this case, for example, would solve the voltage issue on node 7 and the current issue at the line between 3 and 5. And we again can check these. We check these things with the power grid model to validate whether the loads are now. That's what we do with the load flow, to validate whether the loads are now within the capacity ranges that that are acceptable. And that was how we use the power grid model within the IMPI project. And we do this for I did not include it in slide, but to add some extra information there. We did not. We do this for a lot of years, so 40 years, and also we parallelize all our simulations in AWS in a Kubernetes cluster. So we made a lot of forecasts for the future with different scenarios similar to Delphi, but then on the medium voltage levels, where we can predict then what the different outcomes will be given and specific scenarios, and also specific strategies during the years in how you adapt what kind of actions you take to solve, for example, network capacity issues. This gives us a lot of power and insights to make more better argumented decisions on strategies for create for the long term. Final thing I wanted to talk about is, that's one too many, is the Alliander Python Grid, which is a inner source project at the moment. We would like to make it open source eventually. So I'll keep you posted. It's also I think used by Team Delphi, but also used by Team Holonet. So it's a collaborative project, and we use it as the basis for our project. It's based on the power grid model, but it's a bit of a wrapper around it again. So we have a C a calculating core, then we have the Python power grid model wrapper, and then we have another wrapper around that. And the power grid model is more like a calculation tool, and this Alliander Python Grid is more like a data science tool to help you set up like a project, and especially useful for like simulation projects where you want to mutate the grid that you load in, and maybe create new lines, add new nodes, stuff like that. That's what it's aimed to do. I'll show you a few examples of what it can do. It has two representations. So the representation on the left is exactly the same as the power grid model representation. It has like lines, branches, nodes, sources, stuff like that. But we also include a graph representation, which is based on network.it, a Python package. And that allows us to make all kinds of graph logic and questions, ask all kinds of graph questions to our data. I'll give a few examples in the next slides. So it's compatible with the power grid model, and another benefit of this is that we, as different teams, we can discuss, because we have a shared data model. It's much more easy to talk about our problems and discuss our problems, and maybe share code between the projects. Makes it much easier. And we added a lot of extra functionality to add new nodes, stuff like that. And the graph representation is based on network.it, as I said, and uses another module, another open source module, PyVis, for visualizations. And these are the functions that, for example, are included in network.it. So you can calculate distances between nodes. You can find all the nodes another node is connected to, or anything. It's like the basic graph stuff, but very useful for some of the questions we have for our data. And that was it. Thank you. Any questions?
Can I?
Yeah, sure.
Yeah, thanks for the presentation. So I remember this Impact project. You said this the part about AI that you want to use it to make plans for the future.
Mm-hmm.
And what's the motivation behind using AI? Like, why don't you, for example, set it up this whole planning as a, for example, programming or it's an optimization problem and solve that? Then you can have some physical constraints and safety constraints that you can make sure it's safe. But with AI, I don't know. I'm curious how exactly what kind of models you use to approach you use to, for example, to make sure your safety or that is actually optimal, something like that.
Yeah, so we try to steer the AI with reward systems, and it's a reinforcement learning AI. I'm not really sure whether it would be possible. It could be possible to also do it with like what you were suggesting with
optimization.
Sorry.
Optimization.
Yeah, but so with the AI, we just have it run 1 year. We get some reward and we let it steer again. So this is. I'm not the expert on the AI part of this project, but for me, it seems feasible to do this with AI. But so I'm not sure what your suggesting.
Yeah, I also think it's possible and feasible, of course, to use AI. It's just there are, of course, advantage and disadvantage of using AI. For example, if you use reinforcement learning, would it be less sure about safety, for example?
What do you mean by safety in this case?
Because you have AI, maybe I don't know if you have any constraints on, for example, like if it will generate a random image if you enter a reasonable prompt.
Yeah. Well, we did try some test runs, and it does come up with like very ingenious plans. For example, at the first year, it did not connect any application, so it wouldn't have any congestion issue. But you can, of course, constrain the AI also by punishing it really hard if it makes like unsafe decisions, stuff like that. But tuning the AI will be another thing we have to
big point.
And it's not something to be underestimated. It will also be really difficult.
Yeah, thank you.
I think it's also used for strategic questions. So where do we need to go and like find innovative ways that we didn't think about?
So we are not doing the output of our project is not
directly
to be used like directly in for, but it's more like to give like a strategy for long-term processes. So then of course there's going to be another human looking at it, like does it make sense? So that maybe also helps to mitigate that.
Yeah, that's good. Thank you.
We have online question.
I have a question.
Okay, go ahead.
Yeah. Because I'm working on reinforcement learning. I guess my question is that I guess for 1 year simulation, you are doing you can choose actions based on your feedback. So like aiding network capacity and or restore power flow, etc. I want to ask what kind of action you choose. It's a discrete action or continuous action?
So we translate our decisions to money. So for every action, the AI can put a certain amount of money into an action, and then so every year
then the transition model execute.
Sorry.
I say then you after you taking the action, the transition model the environment you build to execute this action and then to give your feedback.
Yeah.
But I guess this problem can also be modeled by optimization theory, because when I was doing reinforcement learning and optimization, and the safety guarantee cannot be maintained because reinforcement learning can get reward from iterations and simulations, but they cannot ensure that it will follow all the guarantees. So now the current project is using after training the reinforcement learning agent, using the decision of this agent as a potential decision for the future.
Sorry, I'm not getting your question.
I mean, actually, right now the AI technology used in this project is reinforcement learning, and after training this agent of reinforcement learning, the decision from this agent is used as a potential decision, but not actually implemented in the real system.
No, it's not going to be implemented. So the output of our project again will be like an Excel
suggestion.
A suggestion, yeah, you could say that. And also, we are not at that stage in our project yet where we really have an AI that makes sensible decisions. So the things you are suggesting with the optimization thing can also be something that we can reconsider in the future. But again, I'm not the AI part of the project, so sorry, I cannot really answer that question.
Yeah, because when we compare the performance, it can be modeled as mixed integer linear programming.
Yeah.
Maybe you can leave your email later in the chat, so
sure.
You guys can have a detailed discussion.
Yeah, sure.
With your team member, because I know this PhD is doing a lot of reinforcement learning. So
sounds interesting.
Yeah.
Okay. Yeah.
Thank you.
Irina?
Yes, hi. I have a question about the different objectives that you include in the AI, because I think it's mostly related to planning, so investment decisions, but you also mentioned something related to maintenance. So these are kind of the responsibility of different departments and would be weighted differently. So how do you combine those together? If I understood correctly, that you consider both operational and investment objectives.
Yes. So the AI has in our AI, we have a minimum of maintenance that the AI has to do. But so that is more like an operational thing. But there are always like extra maintenance things that the AI could do. So it's quite limited in that action, if you consider. But we need to at least incorporate it in our simulation, because we built, for example, in our simulation also new substations, and new substations will include more maintenance as well, which will reduce the amount of technician hours we will have available for other things. So everything needs to be like incorporated because it's all entangled, if that makes it clear.
Yeah, it does.
Thank you. We have another question from Basan.
Yes, thank you very much. I would like to ask about relative to the new connection for a customer you already displayed in the presentation, that you managed to make auto routing or alternative feeding line when we have this kind of network to resolve contingency or maybe violation, this kind of things. Also, do you consider fault isolation and detection?
Sorry, did we consider what?
Did you consider, while you are making this kind of algorithm of a graph multi-routing or alternative feeding buses, that you may isolating fault or detecting, for example, tripping of one switches or blow up of one fuses, something like that, based on the measurement?
I'm sorry, I'm not getting any question. Does anyone else understand? Or can you repeat?
Yes, I am speaking about the slide you represented about the
yeah, I can go back to the slide, maybe makes it clearer.
Yes. There will be one slide speaking about the new connection when you have alternative bus. Yes, this slide. When you are able to choose between different point of connection for a new customer. And this algorithm has been tested for adding a new connection, or you can extend it for isolating, for example, fault or problem in the network.
So we have we try to follow the business logic of Alliander as closely as possible for determining when to create like a new connection between nodes. And we have created separate modules to detect problems within like a substation area. And then after we've detected the problems within, for example, one area, we implement business logic to determine what kind of solutions we will apply to mitigate the problems. And there we try to follow the business logic of Alliander as closely as possible. And sometimes we try to use like also a mixed integer programming to find like the most optimal solution. But it depends a bit on the situation. I hope that answers your question.
Okay, thank you very much.
Maybe, Thijs, can you name one example of so-called business logic?
Yes. So, for example, you can either place a new route between 1 and 7, or you can build a so-called backbone, which is like a really thick cable, which also is like more like a circle. So depending on the amount of some things are done, some solutions are done only reactively. So whenever a client has a contingency issue, then it's done reactively. But we also have a part of our simulation that does things proactively. So a bit like Delphi, we use like future loads. We apply that to our grid. And then we predict like, okay, in 10 years, there will be a contingency problem here. And then you usually tend to go for like bigger solutions, like placing backbones. So that is like business logic we are implementing. An example of that.
Any more questions? Yes.
Thank you for your presentation. So I have one question, because you mentioned a scenario that a new customer is connected to the network. Mm-hmm. And you need to reserve some capacity for the network. Mm-hmm. So what kind of assumption that you make for the new customer, or let's say, how do you forecast the behavior of the new customer?
So we get from other teams, we get data which give like customer data, and then for the amount of power per postal code region. So from that is, and the amount of also the amount of customers that they predict that. So we have that data, and we convert those to customer connection applications. And then so for the next 30, 40 years. And then we have that, we do that in a pre-processing step of our simulation. And then during the simulation, we just try to execute all of those applications, because that's like a law in the Netherlands. They have to be the first come, first serve. So anyone who wants to did their application first is first serve. So we try to do them as many as possible.
Because I'm also doing the data generation. So the new connected customer is already based on the forecast and the prediction. Then you connect it.
Not necessarily, because the only thing we get from the application is the X and Y coordinates. Or I'm saying this. Yeah, we know we draw the X and Y coordinate from our postcode thing, but then during the simulation we have to determine to which node we should connect, because and we cannot know that beforehand, because we're also creating new nodes, and we have to determine also based on whether a node is maybe already overloaded. We don't want to connect there, something like that. Thank you. Any more questions?
I think we can continue our discussion in the coffee break.
Yeah, sure.
Yeah. So thank you for your presentation.
Yes.
Then let's have some coffee break, and all of you will come back at around 15:45.
Yeah.
Oh.
On a power grid model.
So,
stoppen wij in die
Ja.
Eigenlijk een 1-op-1 vertaling, alleen zit er verschillende dingen en
Dus dan, oké, dus jullie hebben dit in een specifiek formaat hangen nu. Want we zijn natuurlijk ook gewoon een Alliander topologiemodel.
Ja, zeker. Ja.
Gewoon voor meer generiek gebruikt zou moeten zijn.
Ja.
Het zou mooi zijn als we zeg maar, die functies daarop beschikbaar zouden.
Ja, zeker. Maar dat heb ik in een vroeg stadium ook met Jaap en Jaap Schout heb ik daar. Maar dat is dan doe je meer op het connectiviteitsregister. Of niet? Ja. En die zijn weer heel erg gebaseerd op het zinnen. Is dat? Maar die standaard sluit weer, dat is net als het PowerGrid, maar dat is een hele gedetailleerde standaard in heel veel opzichten. Dus wij zochten meer iets wat direct aansluit op het PowerGrid model. Dus wij volgen gewoon eigenlijk het PowerGrid datamodel.
Ja. Helder. Ja, wel interessant. Dan weet ik eigenlijk ook hoe InPy werkt.
Ja, leuk. Ik besef ook een beetje, toen ik de presentatie van Bram zag, dat Delphi toch ook wel weer heel erg lijkt op InPy, maar net anders.
Ja, dat is het. Dus ook kan je kijken hoe je de score kan gebruiken.
Ja, zeker. Maar ja, dat is ook een van de redenen waarom we dit samen.
Work for myself now.
For yourself. Oh, nice. Ah.
But I work project for
Grid,
yeah.
grid operators.
Yeah.
Nice. I think I just came. I did a traineeship at Alliander, and I started my traineeship at Impy.
Oh.
And then I took the data science role you had.
Oh yeah.
In Impy, I think for half a year, and then I had. Hope my work didn't make your life very miserable. No, my life was already miserable. Also the challenge of finding the right PowerPoint, but just in case.
So you guys already have some So we are coming back after the coffee break. Thank you. I see also the people upstairs are also ready. I see they are still chatting. So, Guang,
Ja,
headphone on.
zijn er weer.
Hi.
Hey.
So we see have a very nice two presentations. So if you guys can share the presentation with your contact details, then of course
I'll send them to you.
yeah, to me.
Yeah.
That's also possible. Then I can, for those who are interested to have a further discussion or possible collaborations, can you please contact me, especially for the external people from the other DSOs or academics. Now we are talking about a bit more. I would like to talk about a bit more about how Power Grid model is governed. So maybe I forgot to introduce myself at the beginning. So my name is Tony Xiang. I worked at a data analytics group of Alianza as a lead scientific engineer. I'm also the chair of this project. So the first stuff I would like to walk through is how this project is governed at this moment. So we actually have three roles defined in the project. So we have the technical steering committee. I am now the chair of the committee together with Vienna and Jonas. Maybe you guys can wave your hands as I know you both are online. Jonas, oh yeah, I see Jonas there. And so this technical steering committee is more deciding the general and direction of the project, where it headed, and the general priorities. And then we have the maintainer of the project. That's mainly Peter Salming there. Bron Stula and Nitish. Nitish is online. Bron Stula is in upstairs. Yes, thank you. So then it's usually maintaining the issues, pull requests, and so forth. Of course, we have a developer contributors, and of course, anybody can be both contributor and maintainer of those. We started this project as an internal project. So as you see, all the names here are all only Alianza people. That doesn't have to be stay at that way. So actually, we are keen to looking for external people. So if you or your organization thinks you have a good interest to contribute or steering the direction of this project, you are very much welcome to consider join the technical steering committee or the maintenance role. So that is always something possible, right, so Jonas? We can just have external.
Yes, that's definitely possible. So it's definitely not limited to one organization, and we even encourage diversification. So
yeah,
please
exactly.
reach out to Tony.
So that's always we encourage all of you. If you think you want to become a maintainer or even become part of the committee on behalf of your organization, that's always possible. And then I also want to talk about the so-called community-driven development cycle. So we cannot say, oh, let's just look at our head. What is fun? So let's do that. Of course, if you do something very cool but doesn't get used by the people, it doesn't make sense. So we use a community-driven model. So it's a half-year cycle. So every half year we are going to have a meetup. Today is the meetup. And in the meetup, we are going to collect ideas, feature wishes, and tricks and tips and whatever to collect them, and then we can make a half-year roadmap by the technical steering committee. And of course, during you have coming half year with the development plan with the features we want to implement. Of course, in the flow of the development, we always get feedback from the communities, develop some new features, which is interesting for this team or for that project. We will contact them. Hey, we have now this beta version clear. Do you want to try it out before we release it, for example? So this is always a circle. And we have our first meetup is the 1st of June. That's a closed meetup. So let's go to the highlights of Q3. Q4. So the last half year, what we have done, we have the meetup on 1st of June. That's we call it first meetup. That's a closed meetup with only Alianza people. And luckily this time we have the open public meetup with all the people from different parties. What we have done in the past half year is the version 1.4 for Power Query model. We have the grid call integration. We have a new library called Power Query Model IO. That's mainly for data conversions. And we have improved the documentation a lot. So let's walk through it very briefly one by one. So the version 1.4 for Power Query model, that's actually a seamless upgrade. So you don't see any I think almost to none breaking changes. But in the backend we have implemented the 3 winding transformer. So that's a much needed features actually for InPy. Is that guy still there? Yes. So that's actually the one of the features coming from the community. We have another much wanted feature is the iterative or linear current power flow. That's actually very equivalent to backwards forwards power flow in radio grid. But it can also handle a mesh grid. So if you want to know more about this, you can read the documentation. And we then also implement our own in-house smart solver, which not only do we say goodbye to MKO dependency, which was in the past, sometimes can be tricky, but also we get like 5 times performance boost for some scenarios. And this now we can safely say we are order of magnitude faster than other solutions in the market. And so that's the version 1.4. The second highlight is the grid call integration. So for grid call is another famous open source project with grid calculation tools, also including the GUI. So it's a very nice tool used by a lot of people, developed by, I don't know if Santiago is in the call or not, but let me have a look. No, this time. So developed by Santiago, who worked at Spanish TSO. And we successfully worked together with him to make our model as a calculation backend for this model. So if you open the grid call, you have now running PowerFlow, you have now the choice to run Aliana PGM, so Aliana Power Query model. So that's actually one of our first integration to another open source project. So this is really a nice collaboration. The third one is we have made a new library called Power Query Model IO. IO means input output, so that there you mainly handle data conversions. And one of the main data conversion we have done in the past half year is the vision conversion. And for those who don't know vision, especially international participants, vision is a very famous and also well used power system simulation software by Dutch DSOs, developed by Face2Face. Hi, so we have the director also here, by the way. So it's a very widely used, very convenient software with a lot of functionality and a lot of stuff. And but there are people who already have a lot of network data in Vision, and they want to use Power Query model to run this kind of network. And so we've made a sort of a Vision converter. And what it does is it converts from Vision to use the Vision export function to export Vision data to an Excel sheet, and then we have our script to read the Excel sheet and then to make it as a Power Query model input. So this works very fine, and we have already some teams are already using it. We are now working on another prototype of Partner Power conversion. Partner Power is another famous open source tool. So we would like also to have data back and forth convert to Partner Power, and later also try to integrate the Power Query model as an optional calculation core for Partner Power. So that in that way, we hope to bring the performance benefit of Power Query model to existing Partner Power users. So they just need to have an actual argument in their PowerFlow code without migrating their existing code of Partner Power. So that's something we are working closely with Roman from Hofer Institute, but he is in the call, right? If I'm sure. Yes. Thank you.
Hello.
Hi, Roman. Hello.
Hello.
Yes. So we are working very close with Fraunhofer to realize this. Another highlight is the documentations. Previously, we have all our documentations in GitHub. That's sometimes not always very handy with limited markdown possibility. Now we use the reader docs to really build a more professional documentations, and it is more we have now a Power Grid model documentation, which is more or less almost complete, with some still openings to do with mainly on the calculation types. And for the Power Grid model, I/O documentation is a bit less, but then we are also still working on it. So the documentation consists of the menu, so the user menu, so you can select different topics to see which individually you want to read, and including also a full API reference. Then you can see the functional core, what are the specifications of each function, each class, what should be the input, what should the expected output, and so forth. So hopefully with this documentation, we can help the user to get on board more quickly. So that's it from the highlights from the past half year. Any more questions? No? Okay, then it comes to the fun part. So what we are going to do in the next half year, actually the answer is we don't know. That's why we need this meetup. So to gather the wishes from the community to see what the community wants. And of course, we have now a very nice combination of internal and external people here. So what are we going to do now is I'm going to send a link of this link to the teams. Yes. Here, right? Oh, Peter already sent it. Sorry, so I don't need to do it. So if you open your laptop, you can click this link. It will open a mural board. So what you can do is there are 4 types of feature requests. So you can put something here like power system functionalities. So like you want more component modeling or whatever. You can have wishes on the software implementation, the conversion, or other features. And there's another block which is called tips and tricks. So if you want to say, hey, I have used Power Grid model in the past with some good tips of how to use it, you can share it here. And the idea is that everybody online, you can just log into the mural board and then try to paste whatever you would like to paste. There are several sticky notes here, so you can just copy it. And I have 2 things to consider. One is that if you already there are a lot of already issues placed in the GitHub board, but I would request you still put your wishes here so we can have an overview about what is the most wanted for the coming half year. And of course, if you already see a sticky note with your wanted feature, you can paste your thumbs up there, so that knows that this feature is more wanted. So there's another people coming in. And for the people, I think somebody need to mute. And for the people here, if you don't want to use your laptop, that's also fine. You can just shout it out. And my colleague, Peter, he will just on behalf of you to put the sticky note in the sub. And I will give us like 20 minutes time to fill in the mural board, and afterwards we can have a short go through of it if somebody want to explain what elaborate their wishes or feature request in the board. And I would like to come back to Jason Borneo. Are you there from RTE? Jason Benoit.
Yes, I'm here. Benoit Janson. Yeah.
Yes. So one of your features you wanted is the PV bus, right? You just mentioned before. So
yes, that's what I put. I put a post-it in Power System functionalities. PV to have the PV const load generation type.
Yes.
So yeah, that was my first idea. And when we model a TSO grid, we don't have a source, and I think that a source is required for a grid model.
Yes, because in DSO we use source as a sort of a connection point to the TSO as infinite strong bus or something.
Exactly. That's where you have your Slack node probably.
Yeah. Yeah.
And we usually take a PV node for our Slack node. So when I want to use Power Grid model, but I need to have the ability to put many PV nodes, because if I want to model a TSO grid, I have a lot of PV nodes.
So can you also put another ticket about the PV node as a source in the sticker there?
Is it a source? Actually, I don't need any source. If I have PV nodes everywhere, and then we need to choose a Slack node.
Yeah. Oh, I mean, so that's what I mean. Can you just say, can you put another sticker, say PV node as a Slack node, something like that? Yes. Thank you.
There it is.
So as I said, for the people are here, so if you want to also say something, but you cannot connect to Wi-Fi, or for any reason, you can also shout it out, and I or Peter can really make a sticker for you.
Tony.
Yes.
Do you want the name of your face sticking out on it as well, or you don't care? If you have a follow-up question.
Yeah, maybe that's a good idea. So maybe you can put your name and an affiliation or in the sticker. Yes, a good idea, Doctor. And next is boys. That's a good one. Yeah, affiliation should be enough. It's just if you. Net wel mooi.
Ja, dat is toch ook zo. Oh, wel iets ook.
Our director just fled into the upstairs.
行，要连我热点。开了吗？我没有明白怎么用啊。
Somebody moved the thumbs up, so you only have one thumbs up.
I did.那个听的连我一点进去有吗？不是，版本是那个日历里有。小伙伴们，那个小吗？ Die meten, ja,
Onder de changes hebben.
ja, je moet Italië en zou je zeggen, handicap is wel. Je weet wel dat daar in
Dan zou je smart meter moeten worden.
I see some three thumbs up without any. I think that's somebody. I hear some echo here. So maybe is there another person who enabled microphone?
Yes. One of the things I always find difficult with the PDM is the choices you've made with the attribute names. They're like super. What are they based on? They're for our team. It's usually very difficult to determine. Like we have to look in the reference manual, like what does SN mean, stuff like that.
Yeah.
How did you come to those
names?
Those names, and why aren't they long, like fully written out, something like that?
Most of the names are really usually chosen from the common conventions, and to be honest, in that sense we also learn a lot from existing softwares. So most of softwares like R0, which is a zero sequence resistance, that's the common convention in all the power system software. Then we use the same name. Yeah.
So you're just keeping
the industrial convention.
Yeah. It's an unfortunate convention.
but what you can put into the software implementation part is to create something similar data class like what you did for Alianna Python Grid. Then you can have a auto completion from the IDE. Yeah, can you put it in the software implementation side? Then? I see some notes without name or affiliation. Please fill in them in so we know who raised this.
How to do that?
How to do that? You can what?
How to add an affiliation?
You can just change the sticky note, put the parentheses at the end of the text.
Yeah.
You meant auto-completion for array attributes, or?
Yes, auto-completion, yeah, for array attributes, yes. I see Nico have a very interesting question.
I expected a lot of tickets and thumbs up about visualizing. Like Thijs also demoed that we do at IMPI, but I don't see any tickets.
I think that's.
Oh, okay, there is actually one in other. In other at the bottom.
To
okay,
be honest,
great. But then again, I'm not as much of a user, so.
Yeah.
It's also difficult to determine what should be in the scope of the project and what not, right?
Yes. And to be honest, for the visualization part, I cannot say 100%, but it's probably be a bit out of scope here.
I would agree.
Yeah, because actually that's one of the key design choice we made. We don't do visualization and GUI, so it's really about software engineering and software library calculation backend.
Visualization, we could also just create some example or something to show how you can use other visualization tools to easily convert the Power Grid model to a graph representation. So even if we don't have an actual implementation, we can give an example.
We are almost time. Is everybody actually complete? Nog groter. Wel 2 pakken krijgen. If not, then we can maybe would like somebody to elaborate the ticket you have put on, if you think that's necessary. If not, I would like to go through the board a bit to ask questions if I see something I don't understand. Yes, we see the board again. We see a lot of transformer type change with 4 thumbs up. So that says something already. Surrogate model as solver. Somebody from TU Delft. Can you elaborate that a bit?
Yep.
Yes.
This is me. Maybe as far as I know, there are some solvers, linear solvers, and iterative solvers there.
Yeah.
I'm thinking of adding some machine learning based models to the solvers, maybe to speed up more. Yeah.
So what you mean machine learning related models? Is that what you?
Maybe yeah. Machine learning based models.
I guess you mean you want to train the solver. It's just you got input and output.
Yep.
And you don't need to solve this again. It's just a surrogate model between the input and output.
Actually, this is another numerical solver based on machine learning models.
Most of these are very clear. So actually, I have a question for the. I see a lot of tickets named with RB. I think that's who is that? RB? Roman? Or
yes, it's me.
Yeah, shall I write Verhoeven here so to make it more clear?
Okay.
Yeah.
Yep.
And actually, the auto loop controller is a bit related to transformer type change, but that's one of the auto loop controllers. So I'm going to make it side by side. This at least this for me very clear what is here means. Lotte, you say the cost routing. I say you meant here is a short circuit calculation, right? May I change this to short circuit calculation? Yes.
I didn't know the English word for it, so.
Yeah, no problem. So I see a lot of PGM call for Panda Power thumbs up. So Rova, that's something work a lot of work for us to do in the coming half year. Here, Panda Power with Stadium. Oh, can Stadium maybe elaborate it a bit? Why do we want Panda Power integration?
We already have a Panda Power model. So it would save us a lot of time if we could just convert directly from Panda Power to Power Grid model.
We have some working beta versions. Do you think it's possible we can schedule another meeting with you to discuss and let you have a try?
Okay. You correct?
Yeah. Then we'll be starting our to-do list. To be tuned. Stay tuned.
Okay.
Script to convert network data sets received from Alianda to PGM. Who is
Yeah, I did that. So this maybe it's too specific, but for example, we have quite a few projects with Alianda where we receive the network topology data from Alianda. I'm part of one project, the Life project, and it would be if we're talking about the input-output scripts, then it would be nice if there's already something that it's easily, if we receive the data files, we just process it, and then we have a Power Grid model. So that really simplifies the process for us to, because otherwise we have to get master students and they do a lot of stuff, and it takes a lot of time to create the model.
I think this is also something. I think Peter, you noted down the action list, I guess. Can you note it down this question so we can contact you later about what is possible? Yeah.
Absolutely.
Higher conversions. Alianda, who made that? Oh.
Yeah.
Convert graph LV distribution networks into BGM from instruction from his data. Yeah. Liu Dong, huh? I think this also in line with your colleague which proposed, right? So you receive some data, then we need to convert it. And do you also get the data for Alianda or from any other?
No, I just get the data from the open maps.
Ah, okay. Yeah, that's something even more trickier, but we can look into that. Nico Hick has a very nice proposal with together independent power board. So there are something. Oh, we have actually here a lot. So let's let's see if we see something. More examples in documentation and unit in the headers. I'll be more into that. I see someone. Yes, there's one from TU Delft, Wang Chengguang. So we actually already have the discussion forum, which is just a GitHub discussion board. So this question we can actually answer it very easily. So if we go to Power Grid model, there is one site called discussion. If you go there, then you can just post your questions or anything. So I've now pasted the link to the chat. And it's also in the support documentation. So in the documentation, in the support page, we also said that you can go to discussion board to post your question. So I would move this ticket out because it's already handled. More documentation on array attributes, how I can affect results. I think that's something very useful. It's also a big thumbs up with 2 short thumbs. Lei, can you explain your ticket here?
Yeah. Yeah. When I developed some codes and I put in a pipeline for CI/CD, usually there will be as a commercial software. Usually there will be a web source scanning. We check some security flaws in a source code.
Yeah.
Yeah. If it is not passed, then we cannot use this package. So basically, I wish, yeah, if you could already just check against some common web source scan.
Very good questions, and luckily we have that too. Okay. So we use that in SonarCloud. So if you go to SonarCloud here, it actually checks everything: security hotspot measures, code coverage, test coverage, code quality bugs, and how to say, code smells, anything. So this is where we check.
Okay.
Is that what you expect?
I've seen some companies use another tool for this security check, but I think the SonarQube.
SonarCloud.
Yeah, it's
Is
also
SonarCloud
good.
also checking packages, or is it just checking your own written code?
I think it only checks our own written code.
Yeah. Then yeah.
You also have
If you have
dependable,
any
right?
dependencies, then
That's actually a good one. Maybe we could state it, including the dependencies. Yeah.
Yeah.
Good one. Followed network model as a graph. I think this one, if we someday make the Alianda Python grid open source, then this will be an easy task. Yeah, the other one is from Alianda open source code. The last one is from Ho about wish to have access to intermediate data of the network. Can you elaborate here a bit? What's the reason you would like to have it?
It's just related to my research. It's sometimes I need to use the instance matrix, and Y matrix is built by the when you're calculating the power flow to do extra calculation for myself. So I search for this this function in PandaPower, and it's super convenient for me. So I also would like Power Grid Model can provide such a feature. This means I guess this means it's just that you provide a function or provide a Panda data a data frame that when you're calculating one-time power flow, you just store the data into such an intermediate data frame, and then users can access this.
Yes, the detailed implementation, we have to think about it, but I can now understand your use case. So why do you need it? Now I understand. Thank you for your suggestion.
Also, maybe I can chime in. For my research, I also need the Jacobian matrix.
Okay. That's you for Hofer, huh? Okay, thank you. So that's a lot of work for us to do. But we will see. Let's after this we are going to think about what is sensible, what is feasible for the common half year to do given our capacity, and of course the prioritization and between the needs of from different parties. And
maybe you should also just ask the community to build it if they really need it.
Yes. So that's also one way to go. So actually, we want this kind of a community-driven model. So as I said, this come back to the original question. So if all of you want to become as a maintainer, contributor, or even a member of a steering committee, that's always possible to discuss. And especially if you feel that your organization have a good interest here. And so maybe we can wrap up a little bit. This is the second meetup, but also the first public meetup here with a lot of participants. We really appreciate that you all of you can come also online, the people online. And I hope that we can have a good new development in the coming half year. So somewhere in June, I hope to see all of you again. And maybe here, maybe another location, who knows. And then we can present the new results and maybe also presentations from other teams, even outside external parties about the use case. So it's time now. We are very on time this time today, so that's very good. So let's close this session and then get some drinks. And for the people who are online, thank you for your attention and also very much appreciated input in the Mural board. And for those people in the upstairs, please come to downstairs so we can have a drinks together. Yeah.
Okay, thank you.
Bye bye.
Thank you. Bye bye.
Bye bye.
Bye bye. Thank you.
Slaat gewoon voor een simulatie. Gaat ook lekker.
Fout.
Dat vind ik een architect.
Oh.